Good day, good people. Um, Let us look at your compound angles identities. Okay. Now, if you are given the compound angle identity of sine, this is how you will express it. Sine A plus B. In expressing it or expanding it, it will be sine A multiplied by cos B plus sine B cos A. Okay, now check this. You are having a plus here in that bracket for those angles, and when you expand it, you will have a plus as well there. Okay, then if you are having A sine A minus B, then in expanding it, it will be sine A multiplied by sine by cos B minus sine B multiplied by cos B. Check this. You start by saying sine A multiplied by cos B. Then when you put the minus sign there, in expanding it further, it will be sine B multiplied by cos A. This is the compound angle identities for sine. Okay. Now look at the sign as well. If you are having a sign, if you are having a negative sign there, you will have a negative sign as well there. Okay. Now you are having sine A plus or minus sine B equals to sine A cos B. Now if you are having a plus, you will have a plus as well. If you are having a minus, it will be minus um, sine B cos A. Okay. Now let's look at the cos one. The cos one, you are having cos in compounding it or expanding it, it will be cos A multiplied by cos B. Cos A multiplied by cos B. Then it will be minus sine A multiplied by cos B. Okay. Now, if you are having a plus there, here it will be what? A minus. Here it will be a minus. Now, if you are given cos A minus B, then it will be cos A multiplied by cos B plus sine A multiplied by sine B. If it's a minus, then here it will be a plus sign. Okay, check this. You are having cos, open bracket, A plus or minus B. In expressing it, it will be cos A cos B minus plus sine A sine B. Now, if it's a minus, it will be a plus. If it's a plus, it will be a minus. Then for tan, this is what we have as our compound angles. Okay, never mind me on the compound bar. I've been teaching strength for too long now. We are talking compound bars. Now, if you are given the tan, then in compounding it, it will be tan A plus tan B divided by 1 minus tan A multiplied by tan B. Now, check here. If you are having a plus, at the bottom it will be what? It will be minus. Okay. Then on top it will be plus. Then for minus 1, it will be tan A minus tan B. Now check this. It will be plus, then at the bottom minus. Then it will be a plus, then at the bottom it will be at the top it will be minus, at the bottom it will be plus. It's 1 plus tan A tan B. Now the next thing that they would want you to do is to prove this or to derive how did they derive that. That's one of the things that we need to look at in applying your compound angle principle. There it is. Derive the following identity. Okay, we are given tan A plus B. They want us to derive it. What is it that we know about tan? We know that tan theta, it is sine theta over cos theta. That's how we are then going to derive the identity of tan. Now here we are having, we'll then express our tan in this form. We are having sine A plus B over cos A plus B. Then we know that the compound identity of sine would be sine A cos B. It's a plus, it will be a plus, then it will be sine B cos A. All over, we are having a cos, it will be cos A multiplied by cos B. It's a plus, then it will be minus sine A sine B. Then the next thing that we need to do is to divide our numerator and our denominator with cos A sine A. Now let's do it. We are having sine A cos B divided by cos A cos B plus sine B cos A divided by cos A cos B. That's what we said, that we will then divide our numerator with cos A cos B, and the denominator, it will be divided with such. Now we are having, as our denominator, we are having cos A cos B minus minus sine A sine B. Then we will then divide it. We will then divide it with cos A cos B cos A cos B. Okay. Now cos B and cos B will cancel out. Then cos A and cos A will cancel out. Okay. Cos A and cos A will cancel out, I mean to say. All right. Then what is it that will be left with? Then here, cos A will cancel out. Cos B and cos B will cancel out. It means we are having this divided by that, it will give us 1. But here, when we divide this by that, we'll get 1 or cancel out. Then any number multiplied by that number, it is that number or that symbol. Now here, we are having sine A cos A, of which it is tan A, plus sine B over cos B, that is what? Tan B. Divide by, here we are having cos A cos B divided by cos A cos B equals to what? To 1. Minus, okay? Then here we are having sine A divided by cos A. It will be tan A multiplied by tan B. We have then expressed this in a form of that. This is how we derived this identity. This is how we derive this identity. Okay. This is how we derive this identity. Please don't forget that. Let's do some application. You are given cos 75 and they want you to simplify without the use of a calculator. Now, the first thing that you need to do is to express your 75 in your special angles. Okay. Now, it will be cos, open bracket, we are having 30 plus 45. Cos 30 plus 45, 45, it gives us what? 75, isn't it? Then we can then, from here, we can then expand this using the compound principle. In applying the compound principle, we will then have cos 30, cos 45, it's a plus, it will be minus, then it will be sine 30, then it will be sine 45. Then from here, we can then apply your special angles or your right angle, okay? If this is 30, that's 60, that's 1, that's 2, then this is root 3. Then of a 45, 1, it's 45, 45, it's 1, then it's root 2. Now, we'll then apply your special angles in solving this without the use of a calculator. Cos 30, it is root 3 over 2. Multiply by cos 45, it is 1 over root 2. Minus sine 30, it is 1 over 2. Multiply by sine 45, it is what? It is opposite over. It is 1 over root 2. That's what we have there. Okay. Then from there, it will be root 3 multiplied by 1. It gives us root 3. Divide by 2 multiplied by root 2. Minus 1 over 2 multiplied by root 2. Then here we can take out the denominator as we can look at the common factor under your denominator. Then we are having 2 root 2 divided by 3. It will be, how many times does this go in there? It goes 1. 1 times that, then it will give us, right. How many times? Then it will be minus 1. That's what we have there. We know the simplification thereafter. Then from here, this is how you need to do it in simplifying it further. You will multiply the numerator and the denominator with root 2. Root 2. Now, you will then have root 3 minus 1 multiplied by, then it will be this multiplied by that, it will be root 2 multiplied by root 3 minus 1 multiplied by root 2, then it will be root 2. Then you take out the common factor, then you will have root 2 open bracket 3 minus 1 close bracket divide by. Then at the bottom, root 2 multiplied by root 2, it gives us what? 2. 2 multiplied by 2, it gives us 4. We have solved it or expressed or simplified without the use of a calculator using the compound using the compound angle principles. Okay, using the compound angle principles. That's what we did there. Okay, we've applied the special angles. We've expanded the 75 using the special angles. Then we expanded using the compound. Then we solved without the calculator. Now let's look at this one here. Okay. Now remember, when you are looking at this, they want us use the appropriate compound angle. Now you can tell that this is your sine. This is your sine compound angle identity. What is sine? Sine, it is, we are having a minus there. It will be A minus B. How do we express this? It is sine A cos B minus sine B cos A. That's exactly what we have here. Can you see that? Now, in solving it or simplifying, we are given this form. Now, in simplifying it, we will then take this whole given function there to that compound angle identity. It means we will express that as that here. It means here we are having sine 69 minus 24 equals to sine 69 minus 24 equals to 45. Then from there we can use the special angles. We can use the special angles. Opposite over, the answer there would be 1 over root 2. This is how you solve it. This is how you solve it. We are done solving it. We've expressed it in that manner. That's what we are supposed to do. And that's exactly what we did. Then you can then rationalize. In rationalizing, you need to multiply by root 2 over root 2. Then you are having root 2 over 2 if you are rationalizing it. But anyway, that's what we need to do in simplifying it without the calculator. We need to take this step and rationalize the whole thing. Now let's continue with the application. Now we are given the cosec. They want us to prove if the cosec equals to sec. Now let's do that. We know that this is the inverse of sine. We are having cosec equals to 1 over sine. It means that's the simplification, or that's the step that we need to take here. We are having 1 over sine 90 minus x. Right, we are proving that this equals to that. That's what we are proving. But the first thing that we need to do is to write it in that inverse form, so that we can be able to apply the compound principle. Then from here we can apply the compound principle. Then we are having 1 over sine 90 multiplied by cos x. We are having a minus. It will be a minus sine x multiplied by cos 90. That's what we have there, isn't it? Equals to 1 over what is sine 90? Sine 90, it is 1. 1 multiplied by what? By cos x, minus sine x multiplied by cos 90, it is 0. Then here we are having 1 over cos x. Then 1 over cos x equals to sec x. This is what we have as our, that's what we have there, good people. Okay, good people, let us continue with the application. Let us continue with the application. Now, let's look at this one. They want us to prove that cot. Now, let's look at cot. Rather, let's look at tan. Tan theta. It is expressed as sine theta over cos theta. If that means cot, it will be cos theta over sine theta. That's exactly what we need to do here. For us to prove that it is that. That's exactly what we need to do. It will be cos 90 minus x divided by sine 90 minus x. Right. Then from here we can apply your identities. We are having cos 90 cos x. It's a minus, it means it will be plus sine 90 sine x divide by sine 90 multiplied by cos x minus sine x multiplied by cos 90. Okay, then from here we can then ask ourselves, cos 90 equals to what? To 0. That means here I'm having 0 multiplied by cos x plus sine 90, it is 1 multiplied by sine x divide by sine 90 equals to 1 multiplied by what? By cos x minus sine 90 sine x multiplied by, it will be sine x multiplied cos 90, it is 0. That's what we will have there. Then on top, 0 multiplied by cos, it is 0. Then we'll be left with sine x over this multiplied by 0, it is 0, then we are having cos x. Don't forget, ne, that sine x over cos x equals to what? There it is there. There it is there. Equals to what? To tan x. We have then proved that cot equals to tan x. This is how we apply our compound principle, good people. Then we'll do, if you can do more applications in your book regarding your compound and all that. Thank you, good people.